day everyone. Today I will talk about the Milankovitch parameters and how they help explain long-term climate changes on Earth. So scientists have noticed that beyond our daily weather, the Earth's climate has gone through big changes including ice ages. So this brings us to an important question. What really causes these major climate changes over the thousands of years? In the 1930s, a Slovak mathematician and meteorologist named Milankovitch tried to answer that question. So, he studied how the Earth's movements around the Sun affects our climate over very long periods of time. So, since the Sun is our main source of energy, he wondered if even small changes in Earth's motion could affect the amount of sunlight that planet receives. Some astronomers already knew that Earth's distance from the Sun is mostly stable and that the Earth is tilted as it orbits the Sun. So, they also knew that the tilt stays pointing in the same direction. But Milankovitch expanded that ideas. He proposed that three very slow changes in Earth's movements could actually change how sunlight is spread across the planet. So Milankovitch came up with these three ideas, which is the Milankovitch parameters, or called Milankovitch parameters. So the first one is the eccentricity, which is the shape of Earth's orbits. So Earth does not always travel in a perfect circle. Sometimes it is nearly circular, sometimes it is slightly oval. This cycle takes around 100,000 of years. So in the past 100,000 of years, the Earth and the Sun is circular, and the another 100,000 of years after that it is slightly oval. So when the orbit becomes more oval, the distance between Earth and the Sun changes more during the year. The climate impact of that is that seasons can become stronger. For example, summers in the northern hemisphere can become colder if Earth is farther from the Sun. Cooler summers means ice may not melt fully, and over time, ice sheets can grow, leading to the ice ages. So the second one is the eggshell tilt, or the obliquity. That means how much Earth leans. So Earth is tilted, but the tilt slowly changes between 22 degrees and 24.5 degrees over about 41,000 of years. So if the tilt is higher, the seasons become more extreme, hotter summer and colder winters. So if the tilt is lower, seasons become milder, cooler summers and warmer winters. The third one is the precession, which is the wobble of the Earth. So precession is the slow wobble of Earth's axis, like a spinning top. This cycle takes around 19 to 23,000 of years. So effect on seasons of this is it changes which part of Earth's orbit lines up with each season. For example, if summer happens when Earth is closest to the Sun, summers become hotter. If summer happens when Earth is farthest, summers become cooler. So these changes affect how much ice melts or built up. If you put the three together, the eccentricity, eggshell tilt, and precession work together to control how sunlight is distributed on Earth over thousands of years. Each change is small on its own, but when combined over long periods, they can cause major climate events such as ice ages and warm periods. During Milankovitch time, many scientists doubted his theory. They believed that the changes were too small to affect the Earth's climate. For them, it seemed impossible that tiny variation in sunlight could trigger huge events like ice ages. Milankovitch believed that small changes could add up over time, but he lived in a time with no computers. All his calculations were done by hand, making the process very slow and hard to verify. Because of this, his ideas weren't fully accepted yet. Newton's law of nature, introduced in the 17th century, helps him understand how small changes can add up over time. So his equation shows that natural processes often work in a cumulative way, meaning effects build slowly but continuously. So this idea is important because it helps explain how the Milankovitch parameters, even though they change very slowly, can eventually influence Earth's climate. When computers became available, scientists rechecked his equations using modern simulations. They discovered that Milankovitch was right. Even tiny changes, when combined over thousands of years, can significantly influence Earth's climate and help explain the timing of ice ages. These ideas also connects to chaos theories, which explains how small changes in a system can create very large effects over long periods. The Milankovitch parameters are a good examples, small orbital changes that lead to a major climate shifts.